These are some great robots. My favorite was always Robbie.
I loved R2-D2. He's my all-time favorite. Oh, and I love BB-8 too.
You know, these are science fiction robots, but there are kids out there today building real robots.
And we want you to get involved with robotics through First LEGO League and First Robotics.
This is STEM in 30.
Hi, I'm Marty.
And I'm Beth, and we are coming to you from the Stephen F. Udvar-Hazy Center in Chantilly, Virginia. Today we're going to talk all about robotics. What a better place to start than in front of the Canadarm.
This robotic arm was controlled by astronauts from inside the space shuttle. Talk about your out-of-this-world video game.
The arm was used to move big pieces of cargo and astronauts, but it was built for space, and it is so heavy that it cannot support its own weight here on Earth.
Running the Canadarm may seem a little bit out of reach, but today's show is all about robotics, and we want you to know, yes, you, even that kid sitting in the back, to know that you can get involved in robotics.
Just like our friends here, they are all involved with FIRST robotics competitions.
FIRST means for inspiration and recognition of science and technology.
We got a chance to go to New Hampshire and meet the founder of FIRST, Dean Kamen. He's an interesting character.
He is an incredible inventor. He may be best known for inventing the Segway, but did you know that started out as the iBot all-terrain wheelchair? He also invented an insulin pump, the Luke arm, a robotic prosthetic arm, and the Slingshot, which is a water purification system.
But the thing that he is most proud of is being the founder of FIRST.
We're going to find out all the cool stuff that these guys do with their robots, but first, let's learn about FIRST. That is awesome. I want to drive it.
Yeah, I know. We are joined by Dean Kamen, inventor, innovator, and the founder of FIRST. Thank you so much for having us here today.
Thank you for being here, and thanking you in advance for helping us promote FIRST.
Well, first, let's start with FIRST. What is FIRST?
FIRST, the word, for inspiration and recognition of science and technology, is a not-for-profit organization I put together 30 years ago this year to do exactly what our name says. Why don't we take the things that kids need to get passionate about, understanding math and science and analytic thinking, and wrap it in the context of a sport. Make it entertaining. Take it out of the requirement, make it aspirational, make it after school, make it something where at the end of the season they don't get a final exam, they get a double elimination tournament. You don't get to 18 years old and say, okay, now that I'm out of school, I'll stop with the sports and entertainment, I'll go have a career. It's too late. You don't say at 18 years old, I'm going to take up a sport. It's too late. We tell all these kids, we're the only sport where every kid on every team can turn pro.
Now, you mentioned that you really want to focus on getting this education to a very young audience. When you go in and look at these teams, what is the youngest group that you go after?
We started with high school because we said high school kids ought to start learning the real engineering skills they need. And they can be mentored by real engineers from industry that can come in and work with the schools. But after a couple of years, you'd go to the events, and there in the stands, the fans would be the younger brothers and sisters of the people on the first team, in the same way that all little kids want to do what their older brothers and sisters do in any other sport. They wanted to do FIRST. So we now have a total of 4 programs, from kindergarten right up to high school and college. But we have FIRST LEGO League Junior, FIRST LEGO League, FIRST Tech Challenge, and FIRST Robotics.
Can you tell us a little bit about the upcoming season?
So we have a strong partnership with NASA. It's the 50th anniversary of people on the moon. So we said this coming year, all 4 of our programs will be themed on space, and it will be very exciting.
It sounds very exciting. I'm looking forward to this upcoming season. Thank you so much for having us today.
Man, I am excited about first. Can I start programming the Lego League robots?
No, let's introduce them first. These are the Cascades Thunderbots, and they are a Lego League team from right here in Virginia.
They're competing in this year's Into Orbit Challenge.
Let's check this out, and then maybe they'll let you program a robot.
Woohoo!
Main engine start. 4, 3, 2, 1.
I am a space nerd, and this looks so cool.
Well, let's get one of our friends here to tell us about the missions that you guys have to do.
So in this mission, the robot has to strike the orange strike pad in order to get the rocket to launch all the way up. So here our robot is doing that.
That's awesome.
Tell us a little bit about the tools you had to develop for this.
For this mission, we built a big arm with a tire and 2 weights, and we have it slam the orange pad there so that there's enough force for the rocket to fly all the way up.
Tell us what kind of robot this is.
So this robot is called a box robot. As you can see, it has 4 different sides which are completely flat, and this makes it easy to put on tools or back up against the wall.
And you just took a piece off of it. Why are you doing that?
So we can switch the tools to do the other mission.
So you use a different tool for each of the missions. So can we see another mission?
Sure.
All right, so which one are we doing here?
These 2. Yeah, these two missions.
And what are those 2 missions? What do you have to do for those?
For this mission, it's called space travel, and you see this big ramp with a little cart here. So what you're supposed to do is send this cart rolling down the ramp by pushing this little plate up.
Okay, and then there's another piece back there too, right? What's
Yeah.
that?
This is called a solar array. You can push this back and forth, and depending on strategy or conditions, you can push it either forward or backwards. We decided to push it forward, and that'll give us some points.
And that actually is a mission that involves the team you're competing against, right?
Yes.
How's that work to be competing against somebody but also have to work with them?
Yeah, if you work with them, you get the full points. But if their solar array doesn't push like ours does, then we get points, but not as much.
Nice.
Okay.
All right, you ready?
So,
Oh, nice. There he goes. That's awesome. Oh, and they're loading up another one.
Yeah, you can load up to 3.
Oh, and there they go. That's awesome. Nice job. All right, so tell us what they're getting set up here.
Okay, so they're setting up a little ramp with wheels. They're gonna do this mission. It's called crater crossing. So what that you have to do is the robot or any craft it sends out has to completely cross between these 2 towers and push this down. It has to go through the towers, not over it or under it. And so we decided to use some tires to and launch them so that it hits the gate and pushes it down.
Nice.
are you guys given directions on how to build these things?
Not the robot, but these missions.
Yeah, these missions were on like instruction sheet.
They're
that-
standard.
So you know what you have to do, but how you accomplish it is completely up to you guys.
Yeah.
Yes.
And there's never any arguments as you're working on this, are there?
There's sometimes there.
Everybody pitches different ideas, and then we like voting to get like the majority wins over what strategy they want to pick.
Or sometimes we like use everyone's ideas together and try to find a way to.
Yeah.
incorporate them into one design.
Yeah.
Awesome. Are we ready? Let's see it. Almost.
Ooh.
You guys are obviously really good at robotics, but are there any other skills that you learned by doing a first competition?
In project, we have different aspects through space. We have to pick a problem and a solution. And the problem that we picked this year was space radiation. So we learned a lot about cosmic rays and how we can solve that.
In core values, we learn how to work together as a team, and we learn how to cooperate better, and we also learn that some of our ideas may not always be used, but we learn how to respect other people's opinions.
Do you each have individual jobs?
So for that, we have strengths and weaknesses. We work by each other's strengths and weaknesses. Like some people are better builders, some people are better programmers, and we all combine that together and make a robot and work as that.
Did you ever have an idea that didn't quite work out and you had to go back and figure it out?
Yes.
What's that like, having to go back to the drawing board?
A lot of times when we build a tool, it won't work. Sometimes we get lucky and we can just change a few things, but sometimes we have to tear the entire thing down and build from the ground up.
That can't be fun.
No. But you learn a lot by going through that process, don't you?
Yes.
If you want to learn more about this challenge and these missions, head on over to our Facebook page. Marty got a chance to talk to the designer, Michael Grenier.
These guys participate in First Lego League. Let's take a step up from middle school up to high school and First Robotics.
I am joined now by Frank Merrick, who is the director of the First Robotics competitions. Thank you so much for having us here today.
Thanks for talking to me.
Tell us a little bit about these competitions.
Oh, the First Robotics competition, I'll have to tell you, it's so exciting. The students love it. We're an international robotics competition. Last year we had 28 countries involved, over 3,600 teams. Teams come together for multi-day events. They're building robots that are about 140 pounds or so, something like that, maybe 2-3 feet by 3 feet by 4 feet, kind of something in that range depending on the rules for the year. They come together, have a great time. It's a sports-like competition. The teams get super excited, and we just love it. It's so great. And it's so much more than a robotics competition as well. We use the term First Robotics Competition, but it is so much more. The students need to get into doing marketing, they do outreach, they do sponsorship development, on and on. They do presentations. It's really much more than just a robotics competition.
I understand that this year is space themed. Do you want to tell us a little bit about it?
2019 is going to be a very exciting year for us because it's the first year when all 4 programs of all ages under first actually have a common theme in that space. And of course, it coincides with the anniversary of 2019 is the anniversary of the moon landing, so important to our scientific accomplishment. And we just have something really special lined up for the teams.
Well, thank you. I'm really excited about seeing these robots, and I really appreciate you talking to us today about it.
Oh, wow! Look at this. This is amazing. Look at the size of this thing. Can I drive?
Wait. Before you break their robot or the space shuttle, why don't you introduce the team to us?
Okay, this is Aegis Robotics, and they compete in the First Robotics competition. Can I drive now?
Okay, whatever. I'm gonna go talk to some other kids.
All right, how do I do it?
Here we go. I've got the rest of the Aegis team while Marty is breaking your robot. Can I ask you some questions?
Absolutely.
All right. That was last year's robot, correct?
Yes, correct.
All right. Tell us a little bit about what that challenge was. And I think you've got a demo.
Last year's challenge was we had to get these cubes into a scale or switch. The scale, which was the centerpiece of the field, was 7 feet high. And the switches were on 2 opposite ends, and they're about 2 feet high, and we have to balance those scales to our favor so we can get points as the game goes on.
Now, I understand that your robot was coming in a little low, and somebody had a pretty unique solution for that.
So how the mechanism works is you grab it from the sides, and it has an elevator lift that's controlled by strings. It moves up and down by using the tension on the arm.
And you were a freshman when you came up with that?
Yes.
And that solved the whole problem?
Yep. Well, I was a bit nervous afterward, but it really helped me get over my fear.
Now, you all are pretty good with robotics, but were there some hidden talents that came out once you joined first?
Yeah, absolutely. I think this goes for all of us here, but we all walked out as better public speakers, better leaders in our community.
Yeah, most definitely.
And I think all of us working as leaders on the team, we get to work with our fellow peers and work towards a common goal of creating an awesome robot for the competition season and creating outreach opportunities in the community, using the more than robots idea that FIRST really pushes for.
You don't know what the Into Orbit challenge is yet, do you?
No.
But once you get the challenge, what happens?
We hold the kickoff ceremony, I guess you can call it, at our cafeteria at our high school. And it's where FIRST displays the live stream for the game and its reveal. And after that, we break into groups and we each come up with ideas. And we take those ideas and we either evolve on them or we discuss them throughout the season. So we're really constantly changing how we build this robot throughout the 6 weeks.
What jobs do you all have? Because you're not all driving the robot.
No.
You're not all building the robots. So what are some of the other jobs that you guys have?
You can start and we can go down the line.
So I was actually the electrical leader for the past year until I passed it on to this wonderful lady right here. And now I'm just a mentor to the younger kids and also helping people say, hey, I need some help with this. I'd be more than happy to help.
Okay. Yeah, I actually work as the chief executive officer of the team now, and I was a CFO for the past 2 years.
Okay.
I'm one of the fabrication leads. Help build the robot, and along with the other leaders and the kids who are in that sub team.
As you heard from my underling, I am now the electrical lead.
Fabrication lead as well, as he said already. Basically, it's helping out to build the robot from the ground up. 50 different ways to stick one thing together.
Since I've joined the team, I've been a programmer, but now I'm also the chief outreach officer, so I organize the different outreach events on the team.
Now, do these robots come in a box with instructions?
Oh, that would be too easy.
What are the instructions that you guys get?
Our instructions are generally just what the game's goals. That's really all they give you, and the specific guidelines and rules you have to follow. Other than that, it's really up to all of us to figure out what we need to do to elevate it and to win the game.
Yeah, more like we get a list of what we can't do rather than a list of what we can do.
Should we see if Marty's broken your robot yet?
Yeah, probably.
Hey Marty, how's it going?
Beth, this is awesome. These guys are amazing. Thanks for showing me how you run the robot. I had a chance to talk to Dean Kamen, not about FIRST, but about what comes second. We've learned a lot about FIRST, but for those students that participate in FIRST, what comes second? What's next?
I'm happy to tell you FIRST really is the first opportunity for them to see how exciting and how accessible and how important to their own life, their own career, science and technology can be. And it's unbelievable to follow these kids once they've had a taste of FIRST and they get more and more and more into it. These kids are now going off to college and they don't leave FIRST behind. In fact, this year at the championship, FIRST delivered $80 million in college scholarships to kids on our teams. It's a powerful network like any other alumni organization, except it starts younger and it's broader. So FIRST hooks a kid, and we typically keep them. I mean, there's over 300,000 volunteer mentors involved in FIRST, and many of them are there now as volunteers and mentors because they were on the teams 20 years ago, or 10 years ago, or 5 years ago.
Tell us about gracious professionalism.
So gracious professionalism is something we right up front added to our game, because while I keep telling everybody FIRST is nothing but using this powerful model of sports, the problem is if you adopted everything about sports, you might not be so happy. In sports, there's bad sportsmanship. In the world of engineering, it's important for kids to recognize you don't win by defeating the opponent. You win by raising the bar for everybody. And you do it in a way where all the competitors end up learning. All the competitors end up winning. Most of the robots lose. I've never seen a robot cry. But all the kids win because of gracious professionalism.
Well, I can't wait to see that on display this season with FIRST. Thank you so much for talking with us.
You're very welcome.
If you visit the Stephen F. Udvar Hazy Center, there are other robots on display. You guys want to take a look?
Sure.
Come on.
There's only one planet that we know of that is inhabited entirely by robots. Somebody want to take a guess about what that is? Mars, right.
You're
okay.
exactly right.
Yeah. Now, behind us is Sojourner, and that was the first Mars rover.
Now, it's fairly small, but how do you think it was powered?
Ooh, solar panel.
You're right. There's a solar panel on top of it that allowed it to get a charge and drive around. How else could you power a rover?
With batteries?
You're right, but how do you think they power a battery on Mars without using solar power? With nuclear power. So Curiosity is nuclear powered. Spirit and Opportunity are solar powered. And one of the cool things about Spirit and Opportunity, they've lasted for 10 years because their solar panels keep getting cleaned off by dust devils. And those were supposed to last 90 days.
Why do you think they sent the tiny little rover up first?
As a test or an experiment?
Yeah, an experiment. Exactly right.
You're exactly right. Now it's named Sojourner. Does anybody know the name Sojourner? Sojourner Truth was a civil rights advocate right after the Civil War, and so they named this after Sojourner Truth.
Sojourner is the rover. Pathfinder brought it there. How do you think they landed Pathfinder on Mars?
Parachute?
That's a great guess.
An airbag. An airbag, just like the one you have in your car. Landed, bounced around.
It opened the pedals, and then the rover was able to drive off.
Now, this one was sent up in 1997, but
NASA is looking at what's next, and the inspiration for some of those robots might surprise you, and some of it might creep you out a little bit. Take a look.
wow, that is really, really cool. I'm joined by Dr. Aaron Parness. He is at NASA's Jet Propulsion Laboratory. What do you do there?
Yeah, so we build all different kinds of wall climbing robots, like the one you just saw. This one is inspired by cockroaches.
How is it inspired by cockroaches?
So on the wheels, it has sharp hooks,
Okay.
and those are similar to the sharp spines that cockroaches have on the bottoms of their legs.
And why cockroaches and not like spiders or?
Yeah, so cockroaches are really amazing because they have such a small brain, but they're still able to climb. So their feet are not doing any thinking, they're just flailing around and they still work. And so it's a mechanical intelligence is what we call it.
And it's not just cockroaches that inspire your work either, because you've got some other things here that I know have been inspired by other animals.
So I would say geckos are probably nature's most amazing climber, and they climb using lots of tiny hairs, nanoscopic hairs on the bottoms of their feet.
And you have an example here. Can you show us how it works?
So this is 1,000 times the size of our robotic gecko hairs. It's about 100,000 times the size of what a gecko can grow on its feet. And if you put this on the surface and push it, you'll see that only the tips are making contact. But if I pull in the preferred direction, you see it's got a high real area of contact and it's sticky. So geckos do this as they climb, where they weight their foot to make it sticky and then release that weight and they can take the foot off. They do that 10 times a second. If you were trying to climb with duct tape, it might be sticky enough, but how do you get it off?
So why is NASA interested in this?
Yeah, there's lots of applications. We want to grab satellites to service them, repair them, refuel them. There's also a lot of space garbage that we'd like to grab onto and move out of the way. Or you can envision a robot that would crawl around on the outside of the space station doing inspection and repair.
Do you want to show us how this works?
Yeah, absolutely. This is an example of a gripper we sent to the space station. The astronauts tested it. If you squeeze together, it's loading up these springs, and that'll put the adhesive in its preferred state, so it's sticky. And then if you squeeze together again, it comes off.
Now, this is the same material that's on this, and I don't feel hairs or anything on here.
That's right. It's too small to feel with your hand, and it's a geometric effect. So it's not sticky to the touch like tape or glue. It's using van der Waals forces, which are this small force between molecules that get really close together. It's incredible that the gecko came up with this idea.
That is really interesting. Thank you so much for joining us.
You're welcome. My pleasure.
This is cool and creepy all at the same time.
Whoa is right. This is our android.
What do you notice about it?
It has a lot of wires.
A lot of wires. What else?
It doesn't look like it's been fully built.
Doesn't look like it's finished, does it? What do you think it was used for?
To walk on the
experiment.
Okay, what do you think they tested it with?
to walk on the moon.
It's a great guess. You're close.
Maybe they used it to test out how humans would react to spaceflight?
Oh, that's another good guess. What else might they have been able to put this in?
Maybe testing how human would act in a spacesuit.
That's exactly right.
This android was built in the 1960s by NASA, and it was used to test spacesuits.
This thing would test how much force was used by a joint in the spacesuit, or it was used for repetitive motions to test those suits. Another way that robots help people.
That's all the time we have for today. So I want to thank the Cascades Thunderbots, our LEGO League team, and I also want to thank Aegis Robotics team for coming here today.
We'd also like to thank Dean Kamen and FIRST for all of their support with today's program.
We also want to thank the Gertrude E. Skelly Charitable Foundation for bringing you the show today.
We want to remind everybody watching that 1 week from today, tune in on Facebook Live. We will have experts answering your questions about robotics. If you have questions about FIRST or robotics, anything is fair game. Send them our way, Facebook, Twitter, email, video questions, and we will get them answered 1 week from today.
And no matter who you are and what age you are, we are encouraging you to get involved with robotics, even you, the kid in the back seat. And don't forget, robotics is the only sport in which everyone can go pro.
Thanks for watching.